Okay, so what's our first step here? Greatest common factor, which is 5x to the third. Good. So when we divide by 5x to the third, what's left over? X squared minus 2x minus, what's 75 divided by 5? 15. And the x to the thirds divide out. So now we're left with trying to factor. 5x to the third doesn't change, but we're trying to split up the x squared minus 2x minus 15. Does that factor? Well, x times x makes x squared. It's a negative 15, so it's going to be one positive and one negative, correct? If I try positive 3 and negative 5, that multiplies to make a negative 15. If I test it, x times negative 5 is negative 5x, and 3 times x is positive 3x. That adds up to a negative 2x, which is what we want. So there it is. Did anybody get that? That one's a tough one. That one's a little bit of a stretch. But we're going to shift gears a little bit, and we're going to start looking at things like this. Of course, you recognize this symbol right here is the equal sign. The command that you're going to be given on these is going to be solve. Now, when you're asked to solve, that means you're going to be able to reduce it down to a variable equals a single number. So x equals a number in this case. Now, what's different about this than the ones we've seen so far is the fact that it has the parentheses in it. Whenever we see parentheses, what does it tell us? Well, it tells us that we're going to have to do something there first. And our first question we always ask is there anything that we can do inside those parentheses? No, there's not. So what's the second question? Is there something that can be done to the parentheses? And in this case, it is times 8. So 8 times 2x is 16x. 8 times negative 7 is negative 56. Now we've reduced this equation to something that we've looked at before. What do we have to do? We're going to add 56, right? So we're left with 16x equals 80. And then divide by 16. X equals 5. And we could go back and put 5 in for the x and make sure that works, and it will. I'll leave it up to you guys to make sure that works. Now, I have students in the past, there's always somebody who asks, couldn't we have divided the 24 by 8 and gone from there? On this one, it would work, but there are some where it would not, and we will get to those in a few minutes. I want you to try this one in your notes. Where do we start? 3 times 5x is 15x. And then 3 times 1 is 3. Good. Equals 33. Now what? Subtract 3. 15x equals 30, and then divide by 15. X equals 2. How many of you had that? Okay, any questions? Just need a little more time? Yeah. Okay, so we said that here again, you could have just divided by 3 and got 5x plus 1 equals 11, and it would have worked. But we said some of them don't work like that. For example, what's different here? Yeah, there's something outside the parentheses, that plus 5. We're going to proceed just like we did the first two. We see the parentheses. Is there anything to do inside the parentheses? No. Is there anything to do to the parentheses? Yeah, times 5. So 5 times 7x is 35x. 5 times negative 4 is negative 20. Then what? We still have the plus 5 there, don't we? And now we can combine the negative 20 and the positive 5. So the 35x has not changed. What's negative 20 and positive 5? You got it. Negative 20 and positive 5 is a negative 15. What's next? We're going to add 15 because you're subtracting 15, right? So 35x equals 105. And then divide by 35. X equals 3. And as always, you can go back and put it in and test it. If x were 3, 7 times 3 is 21, minus 4 is 17, times 5 is 85, plus 5 is 90. So it does check out. So x is 3. Give that one a shot in your notes. Sure. Okay, so our first thing. Parentheses, nothing to do in them, so we have to do something to them. It's times 3. 3 times 4x, 12x. 3 times negative 1, negative 3. Now we still have the plus 7, and it equals 64. What's next? Negative 3 plus 7. So the 12x doesn't change. What's negative 3 and positive 7? Positive 4. Then what? Subtract 4. So 12x equals 60. And then divide by 12. X equals 5. How many of you had x equals 5? Questions? Okay. What's different here? Yeah, it's the 2x that's being added, but we're going to handle it exactly the same way. Again, we have the parentheses, nothing to do in them, so we're going to do something to them, which is times 5. 5 times 3x, 15x. 5 times 1, positive 5. Then we have plus 2x, and equals 56. Now when we go to combine, we have 15x and 2x make 17x. And then we're going to subtract 5. So 17x equals 51. And then divide by 17. X equals 3. Any questions? Oh, I wish. Nice attitude. I like that. I think you got a little peanut butter right there. Try that one in your notes. Where do we start? 4 times 7x is 28x. And then 4 times negative 3, negative 12, minus 5x equals 34. Good. And then 28x and negative 5x makes 23x minus 12 equals 34. And then we will add 12. 23x equals 46. And then divide by 23. X equals 2. How many of you had x equals 2? Cool. I want you to try this one. See if you remember this. Where do we start this one? There's a little quirk to this one. Can anybody tell me what it is? It's the minus, the negative in front of the parentheses. The easiest way to get around that is to treat it as a negative 1 times the parentheses. So now the 2x doesn't change. This is going to be negative 1 times 5x is negative 5x. Negative 1 times 1 is negative 1 equals 14. Now what? 2x and negative 5x make positive 2, negative 5 make negative 3x minus 1 equals 14. And then add 1. Negative 3x equals 15. And then divide by negative 3. X equals a negative 5. Anybody have that one? I didn't give you quite enough time on that one either. But that negative in front of the parentheses, you have to remember, works best if you treat it as a negative 1 times the parentheses and work with it like that. So now in that light, try this one quick. Okay. So where do we start? The first set of parentheses are multiplied by 2. So 2 times 5x gives 10x. 2 times negative 4, negative 8. Second set of parentheses, what do we have to do? Multiply by a negative 1. Very good. Negative 1 times 3x is negative 3x. Negative 1 times 2, negative 2. And of course this equals 4. What's next? 10x and negative 3x make 7x. And then negative 8 and negative 2 make negative 10 equals 14. And then add 10. I threw a 1 in there just by the fun of it. So it's 7x. 4 plus 10 would be just 14. Yes, it should be 4, not 14. You're correct. So it's 7x equals 14 now. Thank you. Then what? Divided by 7. So x equals 2. How many of you had x equals 2? A couple of you? Okay. Of course, our added level of difficulty here now, we can put variables on both sides. Give this one a shot quick. See how it turns out. Tell me where to start. Oops, just a second. I made a bad mistake that it's going to make this one tough to do, didn't I? Does that look better? Okay. Let's walk through this one together since I screwed that up. Tell me what to do. 7 times 2x. Good. 14x. What's next? 7 times negative 5 is negative 35. Then what? Negative 2 times 3x is negative 6x. And then negative 2 times 1 is negative 2. Now what? 14 and negative 6 make 8x. Negative 35 and negative 2 make negative 37. Okay, now I have reduced everything that I can on one side of the equation. Once I've done that, it's time to start looking at both sides together. Now, what's different with this one than any of the others I've seen so far today is that the variable appears on both sides. So what do I have to do? Get rid of one of them, right? So I'm going to get rid of the 3x. It's the smaller one. So I subtract 3x. If I subtract 3x from 8x, I get 5x. So this is now 5x minus 37 equals 13. What do I do from there? We will add 37. So 5x equals 50. And then divide by 5. X equals 10. How many of you had x equals 10? Good deal. A couple of you. So the key is you first reduce everything you can on one side of the equation. And then from there, you combine what you can on the other side. Well, let's test and see how this next one works. I'll even attempt to write this one down correctly for you. There you go. I guess I'll have to stop there since I'm out of paper. Let's take a peek. Where do we start? So we got 3 times 5 here. 3 times 5x is 15x. 3 times negative 3? Negative 3. What's next? Negative 2 times 3, which is negative 6x. And then negative 2 times 4 is negative 8. Now I'm going to stay on the left side here and keep combining. 15x and negative 6x make 9x. Negative 3 and negative 8 make negative 11. Now that's all I can combine over there. Now I'm going to go back to the other side. What can I do on the right side? 5 times 2x is 10x. And then 5 times 7 is 35. Then what? 2 times x is 2x, and then 2 times negative 3 is negative 6, and plus 2. And then 10x and 2x make 12x. Now we have 35, positive 35, negative 6, and positive 2, which makes positive 31. Now what? Well, we still have an x on each side here. We subtract 9x. We get rid of one of the x's because there's an x on each side. 9x is the smaller one. That's why we get rid of it. So we now have negative 11 equals 12x minus 9x is 3x plus 31. And then we will subtract 31. Negative 42 equals 3x, and then divide by 3. Negative 14 equals x. How many of you had negative 14 equals x? That was a tough one. Okay, well, enough of those. We're going to shift gears slightly. And we are going to look at a problem like this. When looking at this one, we have the x over 3 and x over 2. Well, we could look at it as, well, x has been divided by 3, but then x has also been divided by 2. So to work with that, it's kind of tough. There are a couple of ways we can look at this. One of them is to look at x over 3 as being 1/3 x. Because if I think about it, 1/3 times x becomes 1/3 times x over 1. 1 times x is x, 3 times 1 is 3. It becomes x over 3. So 1/3 times x, or 1/3 x, is equal to x over 3. So then what does the x over 2 become? 1/2 x. So 1/3 x plus 1/2 x equals 15. So now here I have to add 1/3 and 1/2. Just if I had 5x and 8x, I would add them together to get 13x, wouldn't I? Same here, 1/3 x and 1/2 x, I have to add them together. 1/3 and 1/2, this is going to be 2/6 and 3/6. So that adds up to be 5/6 x. Now I'm going to pause. Any questions on where the 5/6 came from? That's just 1/3 plus 1/2. Now what would we do? Well, x is being multiplied by 5 6, so we are going to divide by 5 6. Get x. Over here, this is going to become 15 over 1. To divide by 5 6, we're going to multiply by 6 over 5. Very good. Now we can cross cancel. The 15 and 5 gives me 1 and 3. 3 times 6 is 18. So x equals 18. Now you can go back and you can put that in here. 18 divided by 3 is 6. 18 divided by 2 is 9. 6 plus 9 is 15. So it does check out. So let's have you try one. X over 4 plus x over 7 equals 22. See if you can make that one work. So this becomes 1/4 x plus 1/7 x equals 22. What's 1/4 plus 1/7? 11/28. So that's 11/28 x equals 22. What's next? Divide by 11/28. Which gives us that x equals 56. I don't know where the 2 came from. That should be 56. Anybody get 56? A few of you. Good. You're getting better. There's a couple in Superior. New Richmond is empty today, but I've got noticed they were going to be gone. Go ahead and try this one quick. So, where do we start? Yes, x over 3 becomes 1/3 x plus 2x equals 21. Now we're going to add 1/3 and 2 is 2 and 1/3 x equals 21. Now I'm going to pause there. Any questions so far? Okay, so now what's next? Divide by 2 and 1/3. So x equals, so 21 divided by 2 and 1/3. This first becomes 21 over 1. This becomes 2 times 3 is 6, plus 1 is 7/3. But then we still have to flip that over. So the 21 over 1 stays the same, times 3 over 7. 7 and 21 cross cancel to give me 1 and 3. So 3 times 3 is 9. X equals 9. How many of you had 9? Cool, we're getting good at this. This problem might look familiar, and it should because we did it 10 minutes ago. But there is another way we could have gone about solving this. That is using that least common denominator or least common multiples that we've been looking at. What is the least common denominator of 3 and 2? It would be a 6. Now remember, we've been talking about greatest common factor. Greatest common factors are always smaller than the two numbers we're looking at. We're going the other way now, going for least common multiple. Multiples are always bigger than the two numbers. Now what I did is I put the 6 out front here and I put the whole equation in parentheses. What that means is I am going to multiply every piece of this equation by 6. 6 times x over 3. So this is 6 over 1 times x over 3. The 1 and 6 cross cancel, or the 3 and 6 cross cancel to give me 1 and 2. So 2 times x is just 2x. Does that make sense? Any questions on that so far? I just had 6 times x over 3. I could do 6x over 3 divides out to be 2x as well. So now I'm going to do 6 times x over 2. So I make that 6 over 1 times x over 2. Again, I could just multiply across and get 6x over 2 and reduce it. I'm going to cross cancel the 2 and the 6. Both divide by 2 to give me 1 and 3. So 3 times x is 3x over 1. So just 3x. Equals, I hit the equal sign. 6 times 15 is 90. Now what? 2x and 3x make 5x equals 90. And then we divide by 5. X equals 18, which is what we got up above. Now, to me, this is easier to work with as 1/3 x and 1/2 x, and just add 1/3 and 1/2. The reason I'm showing you this is we can run into equations where the variable might be in the denominator, like this one. So 3 plus 2 over x plus 5, 6 equals 5 over 3x. To solve this, we must find a least common denominator. Our denominators here are x, 6, and 3x. So the least common denominator, what is the smallest number that both 6 and 3 will go into? 6, right? Now, when we're looking at least common denominators, least common multiples, it is the largest power of each variable. Remember when we did the greatest common factors, it was the smallest power of each variable? Now we're doing the opposite side. It'll be the largest power of each variable, which is 1. X, it's just x, so it's x to the 1, or just x. So 6x is our least common multiple, or least common denominator here. So what that means is I'm going to multiply this whole equation by 6x. So I have 6x times 3, which is, well, 6 times 3 is 18x. So that part wasn't so bad. 6x times 2 over x. So I make 6x into 6x over 1 times 2 over x. Probably the simplest way to do this, 6x times 2 is 12x. 1 times x is x. What's 12x divided by x? The x's cancel out, it's just 12. Any questions there? So now 6x times 5, 6. So 6x over 1 times 5 over 6. 6x times 5 is 30x. 1 times 6 is 6. What's 30x divided by 6? It's a positive 5x. Now we're at the equal sign, so equals 6x times 5 over 3x. So 6x over 1 times 5 over 3x. 6x times 5 is 30x. 1 times 3x, 3x. We divide. 30 divided by 3 is 10. X divided by x cancels out. I'm going to stop here. Any questions on how I got to this point right here? So now what do I have to do? $18x and 5x make 23x. plus 12 equals 10. And then we subtract 12. 23x equals a negative 2. And then divide by 23. Because 23 is what's multiplying the x. Now, negative 2 divided by 23 is going to give us a really ugly decimal. What if I wanted to leave it as a fraction? Remember, a fraction is a division problem. A division problem can also become a fraction. So negative 2 divided by 23 is just negative 2 over 23. If you could reduce that, you would, but in this case, you cannot. What do you think? That one hurts a little bit. Let's do another example here, and then I'll have you guys try one. Helps if I put an equal sign in there somewhere. Let me correct that. There. So I need to find a least common multiple. I have x, 5, and 2x. For the numbers, what's it going to be? Well, I have 1, 5, and 2. What's the least common multiple there? 10. Okay. 5 and 2, if I had 1/5 and 1/2, I would have to change them into tenths to add them, right? How about for the variable? Largest power is just 1, so just x, right? X to the 1 or x. So what that means is I am multiplying this whole thing by 10x. So I'm going to stop there. Any questions on where the 10x came from? All I did is I took all the denominators and I found the least common multiple or least common denominator for them. So now we're going to multiply. 10x times 4 isn't too bad. What's that come out to be? 40x. 10x times 6 over x. Well, the 10x I put over 1 to make it 10x over 1 times 6 over x. I multiply. What is 10x times 6? 60x. What's 1 times x? X. That divides to make 60. The x's just divide out. So then I have 10x times 2/5. So again, I make it 10x over 1 times 2 over 5. 10x times 2 is 20x. 1 times 5 is 5. That divides out to be 4x. 20 divided by 5 is 4, and there's nothing to divide the x. Equals. On the other side here, I have 10x. So make that 10x over 1 times the 3 over 2x. What's 10x times 3? 30x. 1 times 2x? 2x. So I have 30 divided by 2 is 15. X divided by x is nothing. It divides out. So now what? 40x and 4x make 44x plus 60 equals 15. And then subtract 60. So 44x equals a negative 45. And then divide by 44. X equals negative 45 over 44. If you left it like that, I'm okay with it, or you can make it as a negative 1 and 1/44. What do you think? No comment? Let's have you guys try one. Give that one a shot in your notes. See what you come up with. So we have denominators of 4x, 6, and 2x. What is our least common denominator going to be? Well, for 4, 6, and 2, it would be 12. 12 is the smallest number that all of them go into. Any variables? Yes, x. So do you guys want me to pause and let you try it now that you have the right common denominator? You had it? Okay. I'm going to give you a minute to go through it with that denominator if you didn't have it, and then we'll talk about it in a second. I know some of you aren't done yet, but let's go ahead and take a look at this. So we're going to multiply the whole thing by 12x. So 12x times 7 is 84x. Next, we have 12x times 3 over 4x. So 12x over 1 times 3 over 4x. 12x times 3 is 36x. 1 times 4x is 4x. So if I divide, 36 divided by 4 is positive 9. X divided by x divides out. So now I have 12x divided by 5, 6, or times 5 sixths. So 12x over 1 times 5 over 6. 12x times 5 is 60x. 1 times 6 is 6. So now 60x divided by 6, 10x. Equals on the other side over here, 12x divided by 7 over 2x. So again, it's 12x over 1. Did I say divided by again? No, times 7 over 2x. Sorry. 12x times 7 over 2x. So 12x over 1 times 7 over 2x. 12x times 7 is 84x. 1 times 2x is 2x. 84 divided by 2 is 42. And x divided by x divides out. So I'm going to stop here. How many of you made it to this point? 84x plus 9 plus 10x equals 42. Perfect. What do we do next? 84x and 10x make 94x plus 9 equals 42. Now we've combined everything we can possibly combine, so now we're going to go ahead and subtract 9. So 94x equals 33. And then divide by 94. So x equals 33 over 94. And that cannot be reduced, I don't believe. So that's it. X equals 33/94. How many of you got that? A couple of you? Okay. The good news is we are almost done for the day. The bad news is now we're going to look at something like this. 4x squared plus 7x minus 2 equals 4x squared minus 2x plus 34. Yeah, 4x squared minus 2x plus 34. Now looking at this, there's an initial panic. We have not solved equations with x squared in it before. Fortunately, in this equation, it works out that we don't have to, because we have variables on each side. We need to get rid of them, or get rid of one side of them at least. If I go to take away this 4x squared, it's gone. That would leave me with negative 2x plus 34. But what do I have to do? I have to take 4x squared away from the other side as well. That can only come from the other x squareds. Well, 4x squared minus 4x squared is 0. It canceled out. So even though there's an x squared in the equation, it's there twice and it ends up canceling itself out. So we're left with 7x minus 2. Now what would we do next? Well, the variable is still on both sides, so we have to get rid of one of them. Which one would we get rid of? The negative 2x is the smaller one, so we're going to add 2x to get rid of a negative. Leaves us with 34 on this side. On the left side, we add 2x to the 7x to get 9x. So it's 9x minus 2. Now what? Well, now we will add 2. 9x equals 36. And divide by 9. X equals 4. So just because the x squared is in there does not mean we cannot solve it. It just means it better cancel itself out before we get around to solving. Similar to that one is one that looks like this. Now here the x squareds are not on opposite sides of the equations. They're both on the left side. But this is asking us to do one of these algebraic operations we've worked with. This is asking us to take x squared minus 3x plus 7 and subtract the x squared minus 4. Where's the x squared going to go? Under the other x squared, right? Where's the negative 4 going to go? That has to go under the 7, under the other ones. Now, what operation are we doing here? We are subtracting. So here's where we have to be careful. This is 7 minus a negative 4. 7 minus a negative 4 becomes 7 plus 4, or positive 11. Very good. What do we do with the negative 3x? Just bring it down. It is negative 3x. There's no other x's to affect it. How about x squared minus x squared? It's gone. It disappears, cancels out. So we have negative 3x plus 11 equals 7. Now what? Subtract 11. So we have negative 3x. 7 minus 11 is negative 4. And then x is multiplied by negative 3, so we are going to divide by negative 3. So we have x equals negative 4 divided by negative 3. First of all, a negative divided by a negative is positive. 4 over 3 becomes 1 1/3. So x is 1 1/3. Or you could have left it as a positive 4 over 3. Either one. What do you think? Okay. There is a new quiz. I believe it is quiz 8. It is due tonight at 11:59 p.m. And then there is a new homework. I believe it is homework 10 that is due for Thursday. I am going to double check just to make sure that quiz 8 has the correct time on it, and it does. So it should be good. And it should be open as of 8 a.m. this morning. So. Any questions for the day? Okay, well, as usual, the computer labs will be open until noon if you want to work on the new assignments, or we'll see them on Thursday.